What is up, AS Math? This is Mr. Knight, and we're back. We're going to be looking at some trigonometric identities. We kind of already talked about them a little bit when we were looking at the unit circle, and these were kind of like the two main ones that we determined and we proved. So let's actually give them some names so we can refer to them. This guy right here, you can call this the ratio identity. I'm a little hesitant saying the ratio identity. There are multiple ratio identities for trigonometry. This is just the one we're going to deal with in this class. Okay, and then this guy right here, we got it from Pythagorean's theorem, so it is called Pythagorean's identity. Once again, there are multiple Pythagorean's identities. And if you're curious, I would go ahead and, if you're really nailing this trig stuff, try to figure out what those other Pythagorean identities might be. It's beyond the scope of this class. You might have to look up some other trig functions because there's more than just sine, cosine, tangent. Anyway, I am getting on a tangent. Let's talk about identities because they are actually different from equations. How so? Well, I mean, they look like equations, right? But here's the difference. Equations are only true for certain values of a variable. So the example that I have right here is sine theta equals 1, and that's only true when theta equals 90 degrees. It is true for certain values of our variable. Identities, on the other hand, are always true for all values of a variable. So if taking our ratio identity up here, it's an identity. So that means if I plug in the angle 30 degrees, it's going to be true no matter what. No matter what I plug in here, it's going to spit out something that is true always. And you're probably looking at that and you're like, Mr. Knight, you made an error, dude. What's up with that, man? Why do you got three lines? I thought there was only two. Well, with identities, it's actually a little bit different. First, though, tan 30 equals sine 30 over cosine 30. Do you believe me? I know we proved it, but I don't know. Let's see if it actually is true. So tangent of 30 degrees, if we bring out our chart, if you have those handy, it might be nice to use our little chart. And maybe you're starting to get these angles a little bit more, which is sweet. But if I want to do tangent of 30, well, apparently that is square root of 3 over 3. So sine of 30, well, that's going to end up being 1/2, and that's going to be over cosine of 30, which is square root of 3 over 2. Okay, so now if I divide these guys, so I do 1/2, and when I divide, I multiply by the reciprocal. I'm going to do 2 over square root of 3. The 2's cancel. I'm left with 1 over square root of 3, and that can turn into square root of 3 over 3. So it is true. The identity works. Math is working. That's good. The universe is not imploding on itself. Now let's talk about the identities and the difference. Like I said, identities use that funky looking equal sign right there. And so, I'm like all over the place. And so, if we replace the equal sign with that, that lets us know it is an identity. And we can actually use identities to prove other identities. And there's really just two main methods to do that. We're going to look at this first one. So the first one is if left-hand side and right-hand side are both complicated with your identity, then move your left-hand side and right-hand side to one side and equal it to 0. Okay, so an example of that would be this identity right here. We're trying to prove cosine squared theta minus sine squared theta is equal to 2 cosine squared theta minus 1. Let's go ahead and, because both sides look equally gross, let's move everything to one side of the equal sign. Let's see what we can do. My biggest tip for this is don't be afraid to get creative. Don't be afraid to try something different. Use the tools you're given, but these problems are designed to be open-ended, which is what makes them so difficult for students. So keep that in mind. Do not be afraid to try something different. Our goal is to either make both sides equal the same thing, or in this case, make the left minus the right-hand side equal to 0, because that would still prove that it's true. Well, let's see what we can do here. Okay, well, we have cosine squared theta minus 2 cosine squared theta. Those guys are like terms, so 1 minus 2 is negative 1. So we get negative, oh, I forgot to equal this to 0. We get negative cosine squared theta minus sine squared theta plus 1 is equal to 0. Now, looking at this identity, it looks rather close to our Pythagorean identity, right? It looks pretty darn close to this guy. And really, you can switch the cosine and the sine around, right? Addition, it doesn't matter. But we kind of have this negative right here. So what I'm going to do is I'm going to factor out a negative out of my cosine and sine. When I do this, it reveals to me that we do indeed have cosine. We have our Pythagorean identity right there. And we know that cosine squared theta plus sine squared theta, that equals 1. So this is negative 1 plus 1. Does that equal 0? Yes, it does. So we have proven the identity, and we are good to go. Okay? If you ever want to like show that you did a proof, I like putting a check mark just to say, hey, I'm done. You could also do this. This means the end of a proof, actually, it turns out. So either way, it's cool. If you want to be like me, awesome. If you want to be fancy, you can do that. Fancy. All right. Now, a couple tips for these, because that one didn't seem too bad, but they can get complicated. Of course it can. My tip is to recognize the alternative forms of identities. So for example, if I have sine squared theta plus cosine squared theta, and that equals 1, I can rearrange that. I can rearrange that known identity. I know now that cosine squared theta, that's actually equal to 1 minus sine squared theta when I move the sine over here. Okay. Likewise, I could do the same thing with cosine. I can move cosine over here, and now I have this new identity. It's the same identity, it's just rearranged a bit. And recognizing that is going to take practice and time, but it can really be the difference in proving an identity or not. Okay? So let's keep that in mind. Let's talk about the second method, right? We don't want to lose too much track. The second method is basically if one side looks way more complicated than the other, just focus on the left-hand side, or whichever side's more complicated, until you can dwindle it down to that simplified side. Okay? So for example, if I have this identity right here, the left-hand side looks way more gross than just tangent of theta. So what we're going to do is we're going to just work the left-hand side and see if we can rearrange it to get tangent of theta. That's our goal. So let's try to do that. One more tip before we actually tackle this guy is, it's supposed to say combining, but combining denominators can be a real difference maker, okay? So that's a good first move right off the bat if we're just working that left-hand side. So let's go ahead and do that. Well, if I want to combine, I have to make these guys have the same denominator. So on this left one, I got to multiply the top and the bottom by cosine. So cosine times cosine is cosine squared theta. And this is going to be over, cosine times 1 minus sine theta. Like that. And then likewise this side, well, I got to multiply the top and the bottom by 1 minus sine theta. So that means I have to do basically this, 1 minus sine of theta. And I would multiply the bottom too, and technically I already did that. Because their denominators are the same, I can combine them and put them all on top, and that kind of makes things a lot nicer. Let's simplify this guy, and let's see if we can come up with something. Alright, now that we have rearranged this equation, let's go ahead, let's clean it up just a little bit. It looks like I can distribute that negative 1. We'll see if that is helpful at all. Okay, well, it looks like we're kind of stuck, but the that's kind of the thing about these. You always feel like you're getting stuck, but you might not be. Let's think. Well, I have cosine squared theta plus sine squared theta. I know that's my Pythagorean identity. But, ooh, it shouldn't be sine squared theta. So we actually just have sine. My bad. We just have sine. So I can't even do that. So we're really stuck. We're not stuck. Okay. Cosine squared theta, the alternative form of that guy, is 1 minus sine squared theta. This is using those alternative forms of identities to kind of help us out. I don't know. Let's change up cosine and see if anything happens. So that turns into 1 minus sine squared theta. And then minus 1 plus sine theta. Now, it looks like the 1's are going to cancel, which is nice. That's dandy. But once again, it looks like we're kind of stuck. Just a little bit. Okay. Well, we're trying to get this to look like tangent. So that identity is sine over cosine, so that's what we should end up with. It'd be really nice if we get rid of this 1 minus sine. Luckily we can. I can factor out a sine theta up here. As such, yeah. Alright, look at that, now we're cooking. And now we have 1 minus sine theta top and bottom. Those guys can cancel. And yeah, sine theta over cosine theta, that does equal tangent of theta. That's one of our identities. I'll try to be fancy this time. Okay. All right. Use those tips to help you on your homework problems. It's going to be easy to get discouraged with these. Try different stuff, okay? And again, you might have to do the problem like 3 different ways before you get the right answer. These aren't as clear-cut as maybe other math problems you're accustomed to, but you're going to rock with what you got. Use your tools to help you out, and I think you're going to do just fine. So if you need help, definitely holler at me. Holler at your boy. This is Mr. Knight signing off.